helium, 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 and that's what
I don't know why, Jackie.
you can't
That's awkward. All right, how's it going, fifth period? This is second period chiming in. We're going to be having our notes. Yesterday we talked about, man, maybe I picked the wrong period to do this with. Okay, so yesterday we went over polar coordinates. Okay, two new coordinate systems. One was this radius or this r value. It's the distance from the pole, so from the center of our axis here, from the pole. Okay, the angle is from our zero line, which is going to be like our unit circle. Okay, so here's just another visual representation. I don't draw very good, and you guys know that, so I didn't even bother trying to draw all the little circles and like all the little lines that would come out of the circle. But I did draw it in a way that it actually lines up with if this was the x-coordinate. Cameron, you weren't here yesterday, please listen. Okay. That this is the x-axis and this would be the y-axis. Okay, so talking about converting between the two, if we were to do that, we can do something right here. If I were to say want to convert between my polar, which is my r and my theta, and I want to change that to rectangular, oh hey, let's rip the paper, that sounds good. Okay, this would be my y-coordinate, and then this would be my x-coordinate. So this would be how far I'd go in the y direction. There's how far I'd go in the x direction. I think I mixed that up, but whatever. Okay, what I've made is a right triangle. Okay, yesterday I gave you formulas. I kind of showed you how it worked, but I think this is a better visual representation of how this would work. So if I were to try and solve for, like, say, y here, okay, and I had r and theta, I have my hypotenuse and I have an angle, and I'm looking for the opposite. So I would use sine. So sine theta would be equal to y over r. So that's kind of where this formula comes in. If I wanted to solve for y, I'd multiply by r on both sides. So r sine theta is equal to y. So remember, I just gave you that formula yesterday. And this is kind of how it's found. All right. The other one that goes along with it would be cosine. So r cosine theta was x. Okay? It's the same process except that x is the adjacent side, so I would use cosine instead. So that's where those two formulas came from. So that was these two that I gave you guys right here. Where x, if we wanted to go from polar to rectangular, it was the x-coordinate was r cosine theta, the y-coordinate was r sine theta. Okay, so that's where those ones came from. Let's say we want to go the other way. If we want to go the other way, we want to go from rectangular to polar. Okay, we have the x and the y, and we're trying to come up with r and theta. Any ideas of how to find r here on a right triangle? So if I have a right triangle and I got my legs, x and y, how could I find r? Pythagorean theorem. Okay, so r squared, right? Let's see, over here it worked. R squared would equal x squared plus y squared, yeah? So then r by itself would just be the square root of x squared plus y squared. Does that look familiar? That's the magnitude of a vector, right? That's how we found the magnitude of a vector, is the x component and the y component, okay? So that's how we would find that one. So that's how we'd get r. How about to find theta? What would be a way we could do that if we only had x and y? Inverse tangent, yeah, exactly. So tangent would be opposite over adjacent, so we could do tangent theta equals y over x, but then it would be theta itself would actually be the inverse right here. Oh, my little thing's in my way. There you go. Now you guys can see it. Okay, so there's my two relationships for rectangular to polar. So that's the example we're going to jump into. Okay, so this is example 4. What we're going to have use these relationships to go from rectangular to polar coordinates. All right, so let's do that. Where's my paper? There it is. We did example 3 yesterday, so that's good. Okay, so I've got this coordinate right here. I'm going from rectangular to polar. Okay, so this is my x and there's my y. I'm looking for r and theta. Okay, it says theta's got to be in degrees. Okay, These ones we're going to have calculators, so we might as well have calculators for this. Alright, so let's start with r. R is just equal to the square root of x squared, so it's going to be negative 2 squared plus the y coordinate, which is 2 squared. Okay? Actually, here are my equations I'm going to use. That was r equals square root x squared plus y squared, and then we have theta equals tangent inverse of y over x. There we go. Alright, so then r, that's going to be negative 2 squared is 4, 2 squared is 4, so that's 4 and 4 is 8. And then we'd have, that would be 2 root 2, really. Okay, so that's going to be r, the r coordinate. Now, so 8 is 4 times 2. 4 is a perfect square, so that you can take the square root, bring that out. That's going to be 2 right there, and then the 2 on the inside will just stay on the inside. Okay? So that's how you get 2 root 2. All right. Now we can find theta. Theta equals inverse tangent of the y coordinate over the x coordinate. Okay? Like I said, I'm all right with this test. We're going to have calculators anyway, so we might as well use a calculator. Inverse tangent of 2 divided by negative 2. Negative 45. So, let's talk about what that means. Negative 45 degrees. Let's actually take a step back. So let's pause here for a second. Let's remember some stuff about tangent, or inverse tangent to be specific. Okay? There were some possible outputs of tangent. Okay? Really the only possible quadrants we can end up when we were doing inverse tangent were the first quadrant and the fourth quadrant. Alright? I don't know if you guys remember that or not, but that's what happened. Okay? When you got a positive angle, it was in the first quadrant. When you got a negative angle, it was the fourth quadrant. So I literally just, I had it drawn already. It's not on your paper. Yeah. This is just quadrants. First, second, third, fourth. Okay. So, from inverse tangent, so possible outcomes from inverse tangent. We would get positive angles in the first, negative angles in the fourth. But that was it. Right? We didn't have any other outputs that would take us in the second or the third. So if we got a negative angle from this result, we got negative 45 degrees, right? What's up? So, before we would do something like that, we actually want to look at something. The point, what was the coordinates of the point that we were given in xy? So the point we were given was negative 2, 2. What quadrant is negative 2, 2 in? It's in the second. So our point is actually over here. But we were given an angle that was over here in the fourth quadrant. Okay? So this is where we get a little tricky with the inverse tangent part. We were given an angle down here, specifically 45 degrees in this direction, negative 45 degrees. But we need this angle right here. This would be our actual theta, would be from our 0 line to here. What do you think? 360 would take us all the way around. That would take us all the way around to here. We just need halfway. We just need to go to the other side. So we're going to add 180 to 45. Okay? So something to pay attention to when we're doing these problems is that, first of all, this point right here is in quadrant 2. Okay? This angle we were given right here is in quadrant 4. So that's the wrong quadrant. Okay? When we're in the wrong quadrant, our theta, we need to add 180 to it. So if we have negative 45, we're going to add 180 to it. Okay? So when you're doing these problems, so our theta is actually going to be 135. When you're doing these problems, these ones right here, where you're going from rectangular to polar, and we're finding that theta, you have to be very careful because you're going to end up in the wrong, you could end up in the wrong quadrant. Alright, so you got to basically add 180 if you're in the wrong quadrant. All right? Does that make sense? Okay. All right, so our coordinates would be 2 root 2, comma 135. Okay, our radius is 2 root 2, and then our angle is going to be 135. That would be our answer to that one. Okay?
So the 135 is what you do
After you add the 180 to our result from tangent.
And you're always going to do that? For 185?
Not necessarily. If you end up in the right quadrant, then you won't. So like this one right here, what quadrant would 1 root 3 be in? So they're both positive. Yeah, it's quadrant 1. So this is quadrant 1. Okay? We'll deal with that in a second. Let's deal with r first. So r is going to be the square root of 1 squared plus root 3 squared. Okay? That's going to be equal to 1 squared is 1. Root 3 squared is just 3. So 1 plus 3 is 4. So that's going to be 2. Okay, so that's going to be our r is 2 in that case. Alright. Then we can find theta. Theta is going to be the inverse tangent of root 3 over 1. Alright, if you remember your inverse tangent values, then you should be able to get that one. But if not, you can do inverse tangent of root 3 divided by 1, or just root 3, be 60. What quadrant is angle 60 in? Yeah, it's in quadrant 1. Is that the right quadrant? Yes. So correct quad. So there's our theta. Theta equals 60. So see, in this case, we didn't need to add 180 to it. We were in the right quadrant. The other one, we were not in the right quadrant. We were in the wrong quadrant. So we had to add 180 to it. So sometimes you have to add it, sometimes you don't. Depends on what quadrant the inverse tangent gets you in compared to what quadrant your original point was in. Right? A lot more straightforward going from polar to rectangular. Don't have to really think about it as much. Okay? Now, last but not least, we're going to convert some equations. So that's going to be down here. So let's convert some equations. We have 4 kind of conversion factors that we can take advantage of, or equations that we can use. We've got x equals r cosine theta. We've got y equals r sine theta. We've got, I'm going to write this one a little differently. R squared equals x squared plus y squared. You'll see why in a second. And then I've also got theta equals inverse tangent of y over x. Alright, so with these equations, what I want to do is I want to make sure, if I'm going like in example 5, if I'm going from rectangular coordinates to polar, I need to replace every x and y. They need to go away. They need to be gone. I need nothing but r's and thetas, okay? Or one or the other, depending on what happens. Okay, I can have nothing, no x's, no y's. I just need to somehow substitute out those pieces. All right? So in looking at this, looking at these equations and then looking at a here, we can start with a. So x squared plus y squared equals r, or 25 squared. 25, there we go. Is there any way I can substitute something from over here so that I can get rid of some stuff over here? Got anything? So I could definitely go x equals r cosine theta, throw that in there, y equals r sine theta, throw that in there, and go from there. I've got something even easier. So x squared plus y squared equals r squared. Check that out. So I can just replace x squared and y squared with r squared. So I'm going to substitute that out and get r squared equals 25. My x's and my y's are gone. Hey, look, mission accomplished. That's all. I mean, technically you'd need to do square root of both sides. But honestly, I'd probably just be happy if you got to that point right there. Okay? So r would equal plus or minus 5, since we took the square root of both sides of the equation. Okay? So really what you're doing is you're looking for ways to substitute out the pieces that you're trying to get rid of. That's really all you're doing.
For the ones that with the X and Y, right?
Mm-hmm. This is going from rectangular, meaning x and y, to polar, meaning r and
So
r and
X and
theta.
Y, can you put R into the Y squared?
No. No. That's because just r by itself, since it's r squared equals x squared plus y squared, just r by itself, so taking the square root would be r equals the square root of x squared plus y squared. And then that, you can't cancel the squares through addition. That does not. So you'd have to leave it like this. Okay? Anytime you take the square root of an equation, then it's plus or minus the result. Okay. If you're just taking the square root of, like it was a square root in a formula, like from earlier, you don't have to do that. It's just plus or minus when you're solving an equation. Okay, good questions, good questions. All right, let's do B. B is 4xy equals 1. Okay, so nothing, no fancy x squareds and plus y squared, so that's probably not going to work. But I do have individuals here. I've got an individual x equation, so I've got an x, and there's an x. Okay, so I can replace that part 4 times, and then that would be r cosine theta. Alright, I've got a y by itself, and I've got an equation with a y that's by itself, so I can substitute out y as well, r sine theta. Okay, that's going to be equal to 1. And there we go, I've gotten rid of the x's and the y's, and quite honestly, I'd probably be happy at that point, because you've gotten rid of the x's and the y's. Technically, simplifying a little bit, it'd be 4r squared cosine theta sine theta equals 1. But that's good enough. We'll call it good there. Okay? As long as you've substituted out your x's and your y's and you have nothing but thetas and r's left, then you're good to go. Alright? You can in a minute. Alright, let's take a look at these ones. Let's go the other way a little bit. So if we've got, now we're in polar and then we're trying to go towards rectangular. So we can do A here. That's r equals sine theta. So, looking at my equations over here, I don't have any of them where r is by itself. I mean, I could take the square root of r squared and then have r by itself, but then that would leave me with the sine theta, so that doesn't seem very appealing. What if I did something else? What if I did this? A little bit of side work here. A little bit of side work. What if I take this guy right here? Y equals r sine theta. We can take those and we can move them around. We can play around with them. I got a sine theta by itself over here. I want to take this guy and I want to get sine theta by itself. So I'm going to divide by r. I'm going to divide by r. So y over r equals sine theta. Okay, so all I did is I just manipulated my equation from before, just to my advantage a little bit. Yeah, let's get rid of that. There we go. Okay, I just got sine theta by itself. So now I've got a sine theta here and a sine theta here. I can replace it with y over r. So now r equals y over r. Okay? R sine theta, yes. Okay, let's get those r's together. So I'll multiply by r on both sides. I'll get r squared equals y. What does r squared equal? x squared plus y squared. So over here changes to x squared. Oh gosh, my pen's going out. There you go. X squared plus y squared equals y. I got rid of x's, or sorry, I got rid of r's, I got rid of thetas. That's it. There you go. It's really weird. You've probably never seen anything like that before, have you? But that's okay. That's it. We're done. We don't need to graph it. None of that. Just there's our answer. Okay? For B, we've got r equals 6. So no thetas, so I don't need to worry about that. Okay. What can I can take advantage of, some side work. It's something that we did already, that I kind of showed. If I want to get r by itself, it's the square root of x squared plus y squared. I got r by myself right here, so I'm just going to replace that with the square root of x squared plus y squared. All in one swoop. I got rid of my r. It's gone. Since my r's and my thetas are gone, I'd say that that's probably good. But if you wanted bonus points, you can square both sides. And by bonus points, I mean just a firm handshake and a pat on the back. Okay. Learning karma points. X squared plus y squared equals 36. Anybody know what shape that is? You seen an equation like that before? We will. We will soon. Yeah. Do you know what shape that is? Nope. It's a circle. Yeah, we'll learn eventually. It's all right. All right. And that is equations. Podvin out.